Welcome to How It Works with Holger. This episode will give you an introduction how to use JSON and Delphi. So in a nutshell, this video will make certain that you no longer think people are talking about a person named Jason. No, it's actually something that has to do with software development. And the agenda of this talk is I'm going to explain very informally, colloquially, what JSON is. I'm not going to give a formal definition. I'm just going to give an example. And with that simple example, we're going to do a demo in Delphi that will be the first step. I'm saying first step. Why am I saying first step? As a famous Jedi once said, patience, young Padawan. Just like the ways of the Force may take a long time to reveal themselves, learning JSON with Delphi is not a snap of a finger, and it will take a little bit of time to get it all. So starting with a simple example will provide a good foundation for you to do more complex tasks with it. And sadly, and this is the positive thing, the way of JSON revealed itself to me, but I'm still waiting for the Force to reveal itself. So let's get started with Delphi. JSON stands for JavaScript Object Notation. JS is the abbreviation for JavaScript and ON, Object Notation. So think about it. It means objects. So JSON refers to objects. It's a representation for objects. And even more precise, it's a string that represents one or multiple objects, and these objects can have a tree structure. So you can even do stuff like a customer and then many invoices, and these invoices can have many invoice items. That's all possible with JSON. But as said, we're going to start with a very simple example. Finally, also a word, why do you need all this, right? I didn't make a slide for this in particular because how it works with Holger is a little bit more colloquial. The thing is, JSON is a format that is used on the web because the web has a lot of JavaScript and it's a text representation that can be read easily. And that's why JSON has become the format to exchange data from A to B on the internet. That's literally it. Like, I hardly know any web service right now that does not offer JSON format. So you read information from the internet and also from other software applications. They offer a JSON export and JSON import. So JSON is really worth learning and looking into as a format. If you're worried about the fact that JSON is, of course, not encrypted, that is due to the fact that if you retrieve the JSON from the internet, it hopefully will be using an HTTPS connection, which is encrypted. And that's the reason why JavaScript object notation itself does not offer any encryption, because it comes from the internet. Another use case for JSON is exporting data from database tables and database tables that have foreign key constraints with each other. And the reason for that is, as I just mentioned, you can have a tree-like structure and export it using JSON. So that makes it very viable to store information that is extracted from multiple database tables to represent information from a database. And that's, I would say, quite a lot of times exactly what web services on the internet return. They return information from databases, and JSON just comes naturally as a data format to represent that information. The example I have put on screen here is a customer class, tCustomer, and the customer has a name property, which is a string, the number of total orders, an integer number, and a double for the balance of that customer. How much money does this customer owe me? And a date when the customer created the last order. That's it. Very simple. First thing to know, as everything comes from JavaScript, and JavaScript does not have the concept of properties like Delphi does. So that is the reason why I listed the fields, starting with an F, a capital F in Delphi, that are tied to the property. The most common misconception in Delphi is that Delphi uses the properties of a class in association with JSON. That is incorrect. Delphi uses the fields of a class. Even though the name might not be the name of the field, because Delphi is smart and removes the F, still, you can only use fields in JSON content. So this is actually a very good example how you can use your class. Like you can set the name, you can set the total orders, but the whole JSON functionality that I explained to you today is tied to the fields. And as far as I know, to any of the JSON frameworks that I've been using so far that are available in Delphi, all of them refer to the fields and not to the properties. And if we instantiate one object of a customer and were to convert it or serialize it to JSON, this is what it would look like. So let's look at this JSON string in detail. JSON starts with curly braces, and that means an object starts. That's what the curly braces mean. And everything inside of those curly braces refers to one object. And then you always have name value pairs. On the left side here in this picture, in front of the colon, you have the name, and on the other side, you have the value. And each of these pairs are referred to, even though JavaScript does not have properties, they are referred to as either pairs or properties. So in this case, the property with the name has the value of type text customer2. Total orders is a number 13. Balance is the floating point number, and last order is a date. And this is where it gets tricky. JSON does not distinguish between anything else but text and number. And you might think like, well, there's a date and there's a floating point. Well, it doesn't matter to JSON. It's a number or it's a text. So that leads to some confusion and no clear standard as of yet how to encode dates as a string, as you can see right here. This is an ISO standard, I should say, but it is not a requirement for JSON. There's many other examples how people use dates in JSON. For example, Unix epoch time is one of the most famous other usages for date time. It's a long integer that is used to express date and time. Floating point, the only way to distinguish it is the decimal point, but for JSON, there is really no distinguishing factor. Text has double quotes and numbers don't have any quotes. And that's what you see right here. And of course, all the different properties are separated using a comma. So name is the property name, and then a text customer2 is the value of the property, comma, next property name, total orders, colon, value, no quotation marks means it's a number. So with that, you already see a problem that there might be some trickiness involved to transfer it back to the data types in Delphi because JSON only has two, more or less. What you also see, if I go back, it is rather common to use camel case for JSON properties. For example, here the name is capitalized in Delphi, or here total orders, T and O are capitalized. And this is the camel case standard that is very common. And especially if you work with other platforms, not only Windows, for example, Apple Swift has JSON retrieval that is based on the camel case standard. So I advise you to use this standard whenever you create JSON. It makes things easier if you need to operate with other platforms as well. So going from here, how do we create JSON for an object? And that's exactly what I'm going to show you. That is the first basic example, because there are dozens of ways to use JSON in Delphi, even without any third party. The Delphi RTL comes with many ways to create JSON. There is streams, there is text readers, text writers for JSON. There is a JSON object, there is a T-pair to really go down onto the level of JSON. There's so much stuff, so you have to start somewhere, right? And this is my offer. We start with simply taking an object and creating the JSON for that object, and of course the other way around. We have a JSON and we want to have an object in Delphi. And that is, in all honesty, this is already a major step to understand and to tinker around a little bit. And from there, we can go the next step of the road. And of course, there is always more than the RTL in Delphi. TMS, for example, offers a cross-platform solution to work with JSON as part of their FNC Core package. FNC Core contains JSON-specific utilities that you can use in the VCL, FireMonkey, and the web to create and read JSON documents. It's very helpful, of course, to have this if you think of web applications that, as with TMS Web Core that TMS offers, you have this at your disposal and you don't need to relearn it because it works the same way in the VCL and FireMonkey if you use the offerings from TMS. But that just as a side note. And the first step that I'm going to show here is completely part of Embarcadero Delphi. The process of converting an object to JSON is called serialization. And the other way around, you call it deserialization. So if some fancy developer says, how can you deserialize this content into an object? Well, it means you take a JSON or any other string representation and deserialize it to create the object again that has been used to create the other side using serialization. That's it. There's no magic behind it. It's just one operation and the inversion of that operation. Before going into the source code, let's look at the example so you get a better understanding. So I can generate JSON based on an object. This is our customer object. And then I'm also able to take this string and convert this into an object again. For example, here I do a show message. Customer has 30 orders, total orders 30, and ordered last on February 14th, right here. So that is the only thing this application does. But with that in mind, you will be able to create JSON and read JSON. So the basic principles are covered. So to generate the JSON, you have to include, or I suggest you start working with the rest.json unit. That offers a particular method to create JSON based on an object. So let's generate the JSON first. And we go to generate JSON. And we have, of course, a customer, tCustomer, and we want to create ljson of type string. The customer, lcustomer, tcustomer.randomCustomer. What did Holger do here? Well, let's look at the tCustomer class. The tCustomer class has a class function randomCustomer, and that returns a customer with a name set to example customer, number of total orders, a random number up to 100, and a balance up to, what did I do, 500,000 divided by 3 to get a floating point, of course. And then the last order as well, using tdate time, now UTC time, and then I increase that value by a certain number of hours and multiply it by -1 because I want the date to be in the past. That's all I do. So this way you can generate your random customer. And as it is a static or a class function, you create result, tCustomer create, and you can use it without actually instantiating the object. So what you do here is you say L customer, T customer, random customer. It replaces the create, so to speak, because the create is being called inside of this method. So this is a very fancy means to create a random customer object. And the tJSON class, I would think, let's look at it. Yes, it's derived of the object. That has all the methods that we need to generate JSON. We can say object to, and we go into the public, we don't go into the private stuff. So you here have object to JSON object, and we have object to JSON string. Forget about JSON object at first. Let's do the object to JSON string. That creates of an object, a object. Let me make that a little bit wider. If you look at the return value, a string. And we have certain options, and these are very, very valuable. You can say that the date is UTC. Do it. Always use UTC time, Zulu time, whatever you want to call it, and set this flag, because that will save you all issues in the long run. Always work with UTC. And then you can force the ISO 8601 standard for the dates. And these here in the back, case, camel, very important. That makes certain that your field names are using camel case for the creation of the JSON. And of course, if you create them this way, you have to make sure that JO date is UTC. You do the same thing if you convert your JSON to object. And JSON to object has as a parameter the JSON string, and of course it returns, and this is the complicated part, I would say, a type T, and that means JSON to object uses generics. So JSON to object literally needs to know what is the class that I should deserialize, and that's all you need to know and pass in, and then Delphi does the rest for you. It constructs the class and fills the properties, the fields with the values from your JSON, which are of course accessible in your properties as well. So going back to the generate JSON method, we see we can call tJSON, and that is also a class function. So we don't need to instantiate tJSON. We can directly call on the class tJSON object to JSON string. What is our object? L customer right here. And then I said JO, I indent case camel to get the camel casing, and my date is UTC. It definitely is because I created it using now UTC. And then I add the JSON string to the memo field. That's it. So it's one line to create JSON. And the deserialization is just as easy. And what I do here, I take the last line from the memo field to make it easy, usable. You don't need to select anything. It just takes the last line. And the customer, L customer, is not being created or anything. You just have a nil reference, so to speak. And JSON to object will instantiate the object for you based on the class tCustomer. So you can call tJSON, JSON to object, and then you pass the class tCustomer, the string LJSON, which is the JSON string, and in the options, which I have forgotten so far, JO date is UTC. In order to make sure if you encoded it this way, you also have to decode it that way. Very important. And you don't need to specify any ident case camel. That's what the function automatically sees because the string is already there. That is more or less a means to generate the JSON a certain way. If you read it, it will be understood. And then we can say show message, customer, L customer, total orders to string, date to string, L customer, last order. That's the show message we're presenting. So it is really, really great that this way we can right away work with our object again. Of course, the downside is, and I'm just going to mention this very, very briefly, you have to declare your class in your Delphi unit somehow. And of course, there is no restriction in Delphi. You can use other JSON functionality that you don't have to tie everything to a class. But as I said, this is the first step. You will be able to generate JSON content and also read JSON content to make your application interoperable with other applications on the web out there. While you watch this, I'm quite sure your fingers are already itching looking at this, of course, and that's why there is no camera. I noticed it while editing the video. Of course, I need to release lcustomer from memory. So I wrap it here and lcustomer free in order to prevent a memory leak from happening. Because lcustomer is our responsibility, it's being created by JSON to object, so we have to take care that it's being freed. So I call lcustomer free after showing the show message, and that is the source code that you will be given that you can download. The mistake is corrected. However, while I recorded the video, I was a little bit sloppy, or excited I should say. I deserialized the object, implemented the show message, and forgot about releasing the object in that case. And that's it. I'll make the source code of this project available. It will be in the comments of the video. And if you like this video, give us a thumbs up. And I already prepared the next video of the series, how to do multiple objects, not only one. So stay tuned for that one.